The most relaxing facts about plasma to fall asleep to. With peaceful cosmos. Let the outside world loosen its grip. Tonight, we drift into a state of matter that glows without burning, flows without spilling, and fills the universe more completely than solid ground ever could. Welcome to the quiet science of plasma. Plasma is matter set free, not locked into rigid lattices like solids, not sliding past itself like liquids, not drifting passively like gas. Plasma is matter whose electrons have slipped their atomic anchors, creating a sea of charged motion where electricity and magnetism are no longer separate ideas, but living forces. Stars are made of it. Lightning is born from it. Invisible rivers of it stream through space, brushing past planets and shaping skies. And here on Earth, plasma hums softly inside screens, lights rooms without flame, sterilizes tools, sculpts metals, and quietly supports the technologies we rely on every day. It is both cosmic and familiar, both violent and gentle, both ancient and modern. So allow your breathing to slow, let your shoulders sink, and follow me into the most common and most misunderstood state of matter in the universe. Most of the visible universe exists not as solid or liquid, but as plasma. When we imagine matter, we think of rock beneath our feet, water in our hands, air in our lungs, but these everyday forms are statistical outliers. The bright universe, the part that shines, glows, radiates, belongs almost entirely to plasma. Vast clouds of ionized hydrogen cradle newborn stars, glowing softly in deep reds. Between galaxies, unimaginably thin plasma stretches across enormous distances, filling clusters like a faint, hot mist. Even the space between stars inside galaxies is threaded with charged regions shaped by radiation, shock waves, and magnetic fields. The universe is not built from solid pieces floating in emptiness. It is built from electrically active matter in constant motion. Solids and liquids are local conveniences. Plasma is the rule. Every ordinary star is a sphere of plasma. A star does not burn the way wood burns. There is no flame, no oxygen, no chemical fuel. Instead, gravity crushes matter inward until atoms can no longer hold themselves together. Electrons detach, nuclei crowd close. The result is a churning, charged ocean where nuclear reactions ignite. Inside this plasma furnace, electric currents flow freely. Those currents generate magnetic fields, which twist, stretch, and rise through the star's surface. Bright regions flare where magnetism concentrates energy. Darker patches form where motion is suppressed. Even the light reaching your eyes carries plasma's fingerprint. The colors and lines in starlight reveal which ions absorbed and emitted energy along the way. When a star twinkles, you are watching light that began its journey inside an electrically alive sea. Free electrons accelerate easily. Ions follow more slowly, but together they carry current across open space. This is why lightning leaps gaps, why arcs stretch through air, why plasma can turn emptiness into a temporary wire. As current flows, heat builds, sustaining ionization. The pathway reinforces itself. Plasma is not just glowing air, it is space made conductive. Plasma twists and threads itself under magnetic influence. Magnetic fields barely affect neutral atoms. Charged particles are different. Their paths curve, spiral, and loop. When currents flow, they create their own magnetic fields, squeezing plasma inward into narrow strands. These filaments appear in laboratories and in space. They are not decoration. They are plasma finding balance. Like iron filings revealing a magnet, plasma turns invisible fields into visible structure. Fusion research tries to tame star-like plasma on Earth. To fuse atoms, matter must be heated until electrons separate and nuclei collide with enormous energy. No solid container can touch such fuel, so researchers build cages from magnetic fields. These fields guide charged particles along looping paths, holding plasma away from walls. But plasma writhes, it ripples, it leaks. Engineers respond with precise field shaping and rapid control. The goal is delicate and bold, a sustained burn that releases more energy than it consumes, a star's core held together by geometry. Space between planets is filled with plasma. Interplanetary space is not empty. It carries a thin, charged wind threaded with magnetic structure. Dust grains acquire electric charge. Fields connect distant regions. Boundaries form where flows change. Spacecraft move through this medium, accumulating charge, enduring particle impacts, and navigating invisible currents. The void is alive. Plasma earns the name fourth state of matter. Begin with gas, add energy. Electrons break free. Suddenly, the material conducts electricity, responds to magnetism, and behaves collectively. This is not just hot or gas, it is matter with long-range communication. Waves travel, sheaths form. Structures persist even when density is vanishingly low. Calling plasma a fourth state is a reminder. Nature has more modes than daily life reveals. Ionization does not always require extreme heat. Strong electric fields can tear electrons loose. High-frequency waves can energize electrons while heavier particles remain cool. Ultraviolet light can free charges. Particle beams can carve conducting paths through air. That is why plasmas can sterilize without burning, why they can clean without melting, why temperature alone does not define them. Plasma is defined by free charge, not by fire. Even a candle flame contains a whisper of plasma. In its hottest regions, molecules fragment. A small fraction becomes ionized. That faint charge is enough for the flame to respond to electric fields, to lean, flicker, and dance. It is not lightning. It is not stellar fire, but even here, the universe's most common state quietly appears. Fluorescent lamps use plasma to make invisible light visible. Electrons accelerate through mercury vapor, producing ultraviolet radiation. Phosphors coating the tube absorb that energy and re-emit it as soft, broad light. No glowing wire, no wasted heat, just plasma translating electricity into illumination. The solar wind is a continuous stream of plasma from the sun. The sun's atmosphere extends far beyond its visible edge. Some ionized matter escapes, flowing outward through the solar system, carrying magnetic fields with it. This wind shapes comet tails, compresses planetary magnetic shields, and sometimes disturbs Earth's space environment. Our star does not end at its surface. It breathes plasma into space. Earth's magnetosphere is sculpted by plasma pressure. Incoming solar particles meet Earth's magnetic field, forming a protective cavity. On the day side, the field compresses. On the night side, it stretches into a long tail. Particles spiral, drift, and store energy. During storms, that energy is released into auroras. This shield is dynamic. It breathes. It responds. The ionosphere is a plasma layer that bends radio waves. Sunlight ionizes the upper atmosphere, creating layers rich in free electrons. Certain frequencies reflect, allowing signals to travel far beyond the horizon. At night, conditions shift. During solar storms, paths distort. The sky becomes part of the circuit. Long before satellites, plasma helped voices cross oceans. Plasma supports waves unknown to ordinary gases. Some waves slosh electrons back and forth. Others ride magnetic field lines like tensioned strings. These motions carry energy, accelerate particles, and shape space environments. Plasma is not just a substance, it is a medium where fields and matter move together. Some plasmas form sharp electrical boundaries. Fast electrons reach surfaces first, leaving charged layers behind. Electric fields build. A thin sheath forms, accelerating particles and shaping interactions. These sheaths matter in chip manufacturing, spacecraft design, and scientific probes. Plasma creates its own edges. A plasma can look calm while particles race at extreme speed. Electrons move incredibly fast. Ions carry enormous energy, yet the glow may appear steady. Stillness is an illusion born of averages. Beneath it, motion never stops. Plasma spans an enormous temperature range. Some plasmas melt steel, others stay near room temperature. What matters is how energy is delivered and where it goes. This flexibility makes plasma both a brutal tool and a delicate brush. Low-temperature plasma sterilize medical tools. Reactive species break down microbes without baking materials. Tiny channels are reached. Residue is minimal. Heat damage is avoided. It is chemistry in air, guided by fields. Plasma can kill bacteria on skin without harming deeper tissue. Reactive molecules act locally. Their lifetimes are short. Effects remain near the surface. Careful control turns physics into medicine. Plasma tools help surgeons stop bleeding. Localized plasma delivers controlled energy, sealing vessels without spreading heat widely. Precision replaces pressure. Plasma jets dismantle stubborn biofilms. Charged particles and reactive species penetrate protective layers, breaking chemical bonds. Structure collapses. Microbes become vulnerable. Plasma cleans where scrubbing fails. Plasma is essential to the tiny circuits inside modern computer chips. Inside fabrication chambers, gases are turned into energetic plasmas that etch patterns far smaller than a human hair. Engineers tune electric fields, pressure, and chemistry so the plasma removes one material while sparing another. The process is directional, precise, and repeatable. It is not dissolving matter like a liquid, it is sculpting matter with charged particles. Every smartphone, every laptop, every sensor depends on layers built and carved by plasma. The miniaturization of technology is not only clever design, it is mastery over ionized matter working invisibly at microscopic scales. Plasma-assisted manufacturing improves reliability, not just size. Thin films deposited by plasma protect surfaces from wear, reduce reflections on lenses, and improve adhesion between layers. These coatings are built atom by atom, evenly bonded and tightly controlled. Devices that survive years of heat, cold, vibration, and touch owe part of their durability to chambers where gas briefly becomes plasma and surfaces are quietly rebuilt. Plasma sputtering coats tools, lenses, and materials with extraordinary precision. In sputtering, ions strike a solid target, knocking atoms loose. Those atoms drift across a vacuum and settle onto another surface, forming a thin, uniform film. It is not paint, it is atomic rainfall. These coatings increase hardness, reduce friction, and shape how light reflects. They appear on cutting tools, decorative finishes, and optical components where performance must endure. Plasma cleaning removes contamination without harsh solvents. Invisible films of oil and residue can ruin adhesion and distort measurements. Plasma breaks these organic molecules apart into volatile fragments that drift away. No scrubbing, no soaking, just chemistry reshaped by electricity. Surfaces emerge chemically refreshed, ready for bonding or coating. Plasma treatment makes stubborn materials accept adhesives and inks. Some plastics resist bonding because their surfaces are chemically inert. Plasma alters only the outermost molecular layer, introducing reactive groups and microscopic texture. Droplets that once beaded now spread. Adhesives anchor. Inks hold. The bulk material remains unchanged, but the surface becomes cooperative. Welding arcs are controlled plasma bridges. Between electrode and metal, gas and vapor ionize, forming a conductive channel. Current surges through, melting metal exactly where needed. Shielding gas protects the molten pool from contamination. Under the sparks, charged particles carry power across empty space, turning electricity into bonds strong enough to hold bridges and ships together. Plasma cutters slice steel with ionized precision. A focused jet of plasma melts metal along a narrow line while rushing gas clears the path. Thick steel yields, curves and shapes emerge cleanly. The tool is both heat source and blade, formed from glowing gas guided by fields. Plasma torches reach temperatures hotter than the sun's surface. In a tiny region, energy concentrates intensely. Metals soften, ceramics yield. Heat is fierce yet controlled. A reminder that temperature is not about size, but focus. Some furnaces use plasma to break down waste. Electrical discharges create extreme conditions that tear complex molecules apart. Organic material becomes simpler gases. Inorganic matter melts into stable, glassy slag. It is not burning, it is forced chemistry. Plasma turns chaotic waste into predictable outputs using electricity instead of flame. Plasma can destroy hazardous chemicals by overwhelming their bonds. Energetic electrons and reactive species attack molecular structures directly. Pollutants fragment into less harmful components. Instead of slow heating, plasma creates an environment where high-energy collisions are common. Chemistry accelerates. Plasma experiments explore turning carbon dioxide into useful chemicals. By energizing electrons rather than heating everything evenly, plasma can activate carbon dioxide in ways traditional methods struggle to achieve. It is not a finished solution. It is proof that stable molecules can be persuaded to change. Plasma-assisted combustion helps fuel burn more completely. Reactive radicals created by plasma can stabilize lean flames and reduce pollutants. Ignition becomes more reliable. Chemistry responds faster. It is guidance, not force. A nudge at the right moment. Plasma generates highly reactive oxygen and nitrogen species. These short-lived molecules drive rapid surface chemistry, sterilization, and odor control. Reactions happen without liquids, only energized air. Chemistry becomes atmospheric. Plasma treatments make fabrics repel water without stiffness. Surface-level modification alters how fibers interact with moisture. Water beads instead of soaking. Softness remains. The fabric stays the same, the surface behaves differently. Plasma improves food packaging safety. By cleaning surfaces, enhancing seals, and enabling thin barrier coatings, plasma helps packaging perform reliably over time. Treatments integrate into fast production lines without added liquids. Quiet dependability built from charged gas. Earth is constantly immersed in solar plasma. Even under a calm blue sky, charged particles stream past our planet, shaping the upper atmosphere and influencing space weather. We live inside the sun's extended environment. Solar storms hurl plasma clouds that can disrupt technology. Energetic particles and magnetic fields disturb satellites, induce currents in power lines, and expand the atmosphere. Auroras are the gentle sign. Infrastructure feels the rest. Coronal mass ejections launch massive bubbles of magnetized plasma. These structures travel for days, carrying embedded fields that can interact powerfully with Earth's magnetosphere. Scale is humbling. A star throws structures larger than planets into space. The sun's corona is mysteriously hotter than its surface. Magnetic loops store and release energy through countless small events and waves. Plasma and magnetism interact in ways still being unraveled. Above the sun lies a hot secret written in fields. Sunspots mark regions where magnetic fields restrain plasma motion. Heat transport slows. Regions cool slightly. Darkness appears by contrast. What you see is magnetism shaping matter. Solar flares are sudden plasma explosions driven by magnetic rearrangement. Stored energy releases rapidly, accelerating particles and emitting radiation across the spectrum. Fields snap, plasma responds, space listens. The heliosphere is a vast plasma bubble inflated by the solar wind. It shields the solar system from some galactic radiation and marks the boundary where solar influence fades. The sun creates not only light, but space weather on a colossal scale. At the heliosphere's edge, solar plasma meets interstellar matter. Flows slow, fields interact, neutral atoms drift inward and become charged. It is a slow negotiation between stellar breath and galactic environment. Comet tails reveal space plasma in motion. Ionized gases are guided by magnetic fields, forming narrow blue tails that point away from the sun regardless of the comet's path. Comets draw the invisible wind in light. Jupiter's magnetosphere is fed by plasma from its volcanic moon, Io. Material escapes the moon, becomes ionized, and is trapped by Jupiter's immense magnetic field, forming a vast charged ring. Moon and planet connect electrically across space. Saturn's rings host dusty plasma. Charged dust grains respond to sunlight, shadow, and electric forces. Dust shifts, clumps, and spreads under invisible influence. Even rings behave like slow electrical systems. The moon has a subtle plasma environment. Sunlight charges the surface. Night-side regions collect electrons. Electric fields form near the boundary between day and night. Dust may loft and move under unseen hands. Mars loses atmosphere through plasma interaction. Without a strong global magnetic field, solar wind plasma can strip atmospheric particles over time. The sky itself erodes. Venus glows in ultraviolet through its ionosphere. Solar plasma shapes the upper atmosphere directly, revealing chemistry and motion through faint light. Even hidden worlds speak in plasma. The Milky Way contains vast hot plasma between stars. Thin, energetic ionized gas fills galactic space, shaping cosmic ray paths and glowing faintly in X-rays. The galaxy has an atmosphere. Supernova remnants are expanding shells of plasma. They seed space with heavy elements and accelerate particles to extreme energies. Death becomes motion. Motion becomes future worlds. Pulsars fling plasma along magnetic poles. Rotation, magnetism, and charge combine to create cosmic accelerators that beam radiation across space. Small objects, immense power. Black hole jets launch plasma near light speed. Magnetic fields channel matter outward even as gravity pulls inward. The universe allows both. Accretion disks glow as plasma spirals inward. Gravity heats matter into ionization. Light escapes before matter vanishes. Falling shines. Some of the universe's missing matter may be hidden plasma. Diffuse, warm, ionized gas may fill the cosmic web between galaxies, faint yet massive. The universe is fuller than it appears. Plasma can organize itself into long thread-like currents. When charged particles move together, they form electric currents. Those currents create magnetic fields, and those magnetic fields can pinch the moving charges inward, narrowing the flow into slender filaments. These filaments appear in laboratories as glowing strands during discharges. In space, similar structures stretch across vast distances, shaping ionized clouds and energetic environments. Nothing solid holds them together. Motion and fields do the work. In plasma, structure can arise purely from movement. When plasma streams collide, ripples and instabilities can grow. Two flows sliding past each other may look smooth at first, but tiny disturbances can amplify, rolling into waves and curls. Electric and magnetic forces add complexity beyond ordinary fluid motion. Energy redistributes. Ordered flow becomes turbulence. Boundaries blur. These patterns matter at planetary borders where solar plasma meets atmospheres. They also matter in fusion devices where turbulence can carry heat away from where it is needed. The patterns can look alive. They are not. They are physics seeking balance and overshooting again and again. Magnetic reconnection allows plasma to release stored energy suddenly. Magnetic fields embedded in plasma can stretch and tangle, storing energy like tension in twisted cords. Under the right conditions, field lines can rearrange their connections. When they do, energy is released rapidly into heat, motion, and fast plasma jets. This process powers solar flares, auroral storms, and sudden space weather events. It is also a challenge for fusion research. Magnetism is not passive. In plasma, it is an energy reservoir with escape routes.